So LB,
Yes.
so that means from what we have just seen today, a while loop can also become an infinite loop if the conditions are not set.
Exactly. So I was also, before the stuff finished, I was trying to just generate an example where you can, if you want the user to repeat something a number of times, right? Something like this. I can ask you to give me a number and tell you to enter a number and negative number to quit. Enter a positive number, let's say a positive, and negative number to quit. And I give a condition that while the number you enter is greater than or equal to 0, so greater than or equal to 0, print the number. Then I go back and ask you for the same number again, right? So this loop, we keep repeating until n is this greater than, okay, no, this should be less than, right? What if, okay, sorry, I'm
It's
confusing
greater
myself.
than now.
Greater than, yeah. So
Positive
anytime,
number.
yes, correct. Anytime n is no longer greater than 0, which means this condition becomes false, right? The loop is going to quit. But the way it is, so far as I keep putting a positive number, this will repeat. Now, I don't know how many times the user is going to do that. I don't know how many times. The user can do 10. Let me just run it and you see for this ones. If I save this, let's see what happens. Then we run it. So it's asking me to enter a number. I say 4. It prints 4 and asks me again, enter another number, 5. Do you get? So far as I keep putting numbers as much as I want. So anytime I put -1, then it quits. Do you see that? So I've achieved this kind of thing now with while loop. When you want the person to do repeat something a certain number of times, you don't know the amount of time, but you give a condition. Anytime he puts this one that doesn't meet this condition, then the loop ends. Okay, so this is how you can achieve something like that. But if you try to do this with for loop, we know that, oh, you're going to do it 4 times or 5 times or 100 times. There's a limit, but with while loop, as long as I keep putting that positive number, it's going to continue to repeat these codes I put here. It must not be one line. It can be lines of code. So that's the idea. That's one way you can use your while loop. Okay, so the next one now is what we call the break statement. Break statement. Have we come across it before?
Us.
Have we come across the break statement?
Yes, I have.
Yes.
Okay, good. Some of us have. So the break statement is used to end a loop, whether for loop or while loop. Let me say without meeting, like, unexpectedly, let me put it that way. For instance, what do I mean? If I bring in a for loop, say for I in range, what's this? Okay. For I in range 10 or say 11. Now, I said if, let's say I'm printing I, as a print I. Now I put if I mod mod 7 is equal to 0. Then I say break. Now, what is this now? I have a for loop that will generate our numbers I from 0 to 10. Okay. Now I'm printing the I, but I then put another condition, an if statement that, oh, if I is divisible by 7, break. Now this will bring numbers 1, 2, 3, 4, 5, 6, 7. The last number to print is 7, and the loop will end. But that, that's not like the end of the loop, because the loop is supposed to get to 10.
Yes.
So yeah, this is going to end the loop. That's what break statement does. It ends your loop before the lifespan of your loop, before you finish the range, like how long you want your loop to run for. If a certain condition is met, you can break it. And this can be used in an example of prime numbers. If I am looking for a prime number, you know that I think we've done it in one of the previous exercises where you try to determine if a number was prime. One of the chapters. If you've been doing the exercises, you remember this exercise. So to solve that problem, you would divide, let's say the number is, let me just say the number is n is equal to the number we are looking at, right? And you could collect it from the user with eval input. You can say the user should supply a number and check if it is prime. A prime number is a number that can be divided by only one and itself. So I think 19 is a prime number. Now you can say for I in range. In that case, you wanted to start in 1. No. Yeah, you start in 2 because it's divisible by 1 to n. So you have a setup like this. And you are running the loop, checking if, in this case, we could say if n is divisible by I, okay, then we can just say break the loop. Maybe before breaking the loop, before ending the loop all of a sudden, we could say print not prime. Because what it means is the moment you find out that one of the numbers can divide, the number we are looking at, which is n in this case, then you know that it's not a prime number. So if I put 15, the moment you're running 15 and you get to 5, 15 is divided by 5. It's even divided by 3. So the moment you get to 3, it will hit a point where this statement will hold. Then immediately you just know that that number is not prime. So you don't need to run this. Let's say if this were 15. You don't need to run the for loop 15 times. Okay? You don't need to run it 15 times. The moment this holds, everything stops. So let's print the loop variable. So if I say print I, we'll now see how many times it will run for 15. Okay? And then we just put this. Now, you can have, if this does not break in the end, then you know it's a prime number, for example. Okay? So let's run it and see what I mean. Save it. Let me run it. So you can see that I tried to print out I, and it ran for I equal to 2. The next I was I equal to 3. But when it ran at I equal to 3, immediately not prime. So you find out that other i's did not run again. Okay, so you've reduced.
You exit the loop.
You've exited the loop, yeah, before it completed its course. So that's what a break statement is for. When a condition is met, the loop is still supposed to run, but you want to jump out of the loop and continue your code, you use the break statement. The same thing with while loop. You can also apply it in while loop. So while n mod I is not equal to 0. You know, in this case, I'm trying to write the same thing now with a while loop. Oh no, let me not put the condition here because that will defeat the purpose of break. You can just say while I is less than n. While I is less than n, print I. Then I put the same condition, this if statement, and put it. So if n mod I is equal to 0, I can just print not prime and break. So this and this are the same loops with for and with while. But you see the break statement used to end the loop once a condition is met. We don't want to continue again. We stop. That's it. So if you come like this, comment this one, make it comment, save the file, run. Okay, so it says I is not defined. Yes, because I'm not supposed to use I. I'm supposed to initialize that I is equal to 0. Remember, I skipped that step. And I'm supposed to grow my I so that this thing can end. I plus equal to 1. Yeah. We save it. Then run again. Zero division. Okay. Who can tell me why this error is coming?
Okay, I think the first 0, whenever you divide the number by 0, it always give this error.
So what should I do to correct it?
Okay, to do that, I think you need to start to initialize the I to 1.
So I initialize it to 1.
Yes.
Okay. I can also tell you that even if you initialize it to 1, it's still not going to give us the correct answer. But that error will not be there. You're right. This will solve the error which we just noticed. Division by 0 will not happen. But because we are dealing with prime, if we now divide by 1, it will tell you that it's not prime from the beginning. Abi?
Yes.
Running. So you can see once you just do 1, not prime. This way now, even though you put a prime number, let's say this is 19, it will be telling you it's not prime. So just the same way when we're doing the range here, we started from 2. Because if we started from 1, this condition will be hit, so you initialize it to 2. That's it. Wait, so I should start from 2 instead of 1. So similar now, we've achieved that same for loop with Y. But the idea is the break statement is used to break the loop. Force yourself out of the loop at any given time. So in this particular example, this particular example I did earlier here, where I told the guy to be bringing, the user to be bringing positive numbers and negative number to quit, I can still adjust it to use a break statement by maybe saying why true. So while true, this should happen. You print n and then check if basically it's the same. No, okay. If n is less than 0, you get, I can even put it
Yes.
before printing anything so that I won't even print a negative number. So I can put it here. So once you come into my loop, the first thing I'll check is n less than 0. If you put a number, even the first time, put a number that is less than 0, it will just break. Nothing will happen. Otherwise, the loop is going to continue looping until you bring an n that is negative. This is the same way to still break the loop. Okay. So that's the break statement. Now, the next one look about is the else statement. Infinite loop, break statement, and the else. So while we were doing this one for prime number, I deliberately did not print out prime because of this other part. So we can have an else statement like this, and you can say prime. Now, this is an else statement that works only if you did not have break. So when you see this structure with your while loop, you have to have a break statement. If the break statement is not met, then you can say prime. I hope nobody is confused.
Yes.
So in this
Confused.
case, yeah, okay. So there's a while loop.
Just explain again.
Before I put this one, let me remove it. I just stopped it like this. We understood that as you put an n, maybe say 19, n is actually here in this line, so it's tied together. So once n is 19, you come to your while loop and run your while loop, each time printing I. And whenever you find a case where 19 is divided by one of the numbers beneath it, which is maybe if 19 is divided by 5, for example. So let me use the case of 15. So in the case of 15, 15 is divided by 3. So once you encounter that part where 15 is divided by 3, your if statement is going to be true. And then you print not prime, right? Then the code will break. So after it breaks, the other question would have been, when it is a prime number, this condition will never hold, which is like in the case of 19. When it's 19, there will not be a time where you find a number that will be able to divide 19 until you get to 19. Am I correct?
Yes.
Because it's a prime number, or if you look at 7, the same thing. So there's no number underneath it that will divide it. So that means that this if statement will never evaluate to true. It will always be false. So you're never going to break out of the loop and you complete the loop. In this instance, the loop will be completed. Now, after completing the loop, how then do you bring out the message that this number is not prime? I mean, this number is a prime number. Let me save this and run it again so we'll see what I mean. So you can see in this case, it printed all the numbers down to 18 because we said yi is less than n. In this case, n is 19. So the moment it gets to 19, it's no longer less than 19 and the loop finishes. When it finishes, okay, we never hit break. Okay, we didn't hit break because it's a prime number. Then how do we then print out that it's prime?
You use another statement. Continue.
Which statement again?
Continue.
Else.
Like
Else print.
Or elif.
Okay.
Else is still.
Here's the thing. We are not using a flag variable. Right? If you remember flag variable, right?
Mm-hmm.
So at the beginning, we're using a flag variable that we set in the beginning to be maybe true. Then whenever this condition holds, we will now change the flag to false. In that case, we can then come here and say if flag is true, prime, if flag is false, not prime, that kind of thing, right? Remember flag variable, we did something about prime when we were talking about flag variable, that you would put as a Boolean either true or false. And based on that, you can determine in the end if your flag changed or not while you are going through the loop. Now, we are not using a flag variable that you would, in the end, be able to evaluate here. What I'm trying to say, let me bring it down practically. So if you're using a flag variable, you can say flag. Flag can be equal to true. What this means is, at the beginning, we are assuming that the number is prime. So here we will now say if flag equal to true. If flag equal to true, we can then say print prime. So in this case, in the beginning, we assume that flag is true, meaning that the number is prime number, until, okay, if we enter here, we now say flag equal to false. Do you see? So if in the end, when we want to evaluate this if statement, when we finish our loop, if we try to evaluate this if statement and flag is not true, then we will not print prime. Okay? This is where we're using flag. If you use a flag like this, now if I run this code again, which I'm going to do, save it. Now it is 19. So I run. You can see in the end, it printed prime because of this evaluation here. Now, if I change it to 15, I might not even need to print this one here, so that I will now just say else. Print not prime. So in the end, I'm evaluating. I can still print it here, but I just decided to use this place so that we'll see clearly what's happening. So if at any point in time now, our flag changes to false, after we finish our loop, we can have this evaluation that will tell us if it's a prime number or not. So now it's 15. It's supposed not to be a prime number. Okay, I need to save it. And I run it. So you can see not prime. It's printing not prime because when it broke out of the loop, we came and the next section of our code evaluated this and told us not prime. Even if I remove the else and allow it to print not prime here, it's the same thing. Okay, I'm just trying to let us see how the flag can help us catch this event. Now, if we are not using flag, so I'm going to reverse back to where we were. There is no flag to help us catch that. But we already ran it in mind that the moment this condition holds, we'll just say not prime. Now, what if this condition does not hold? How do you evaluate and tell the user that this number is prime? Like in the case of 19, when it runs through our loop, this condition will never hold because 19 is a prime number. It never broke the loop. In the end, how do we tell the user it's a prime number? That is where that else comes in. So there's a structure of else with while loop. When you have a break statement like this, after the while loop, you will now have an else. You can then have something there, like print. And I say prime. So what this is now saying in this case is a structure on its own. In this structure, you run your while loop. But if you never hit break and the while loop finishes, then you're going to run this else. But if you hit the break statement, it is not going to run the else. It's a structure on its own like this for your while loops. Like in this case, now we are looking for prime number 19 or 7, which is a prime number. If you run it on this, it will never enter the break statement, okay? Because this will never hold. This condition will not be true. So you're not going to hit break. After you run the whole of the loop, at the end of the loop, you never hit your break statement. Then you will enter else. But if you hit your break statement and the loop comes to an end, you will not enter this else. You will jump it. Let me save it now. Change it to 19. Change it to 19. Need to save. Okay. You see, prime. But if I make it 15, which is not a prime number, save it. Run. You can see that it printed not prime, but it never printed prime because it hit the break statement. And once you hit the break statement, you're not going to run this else. You just jump.
Okay.
Is it understood?
Yes.
Apart from Henry, I hope other people understand it and you're not confused.
I'm confused.
How do I explain it now? So you have an if statement under your while. You know, normally, if and else, they go together. Right?
Yes.
Normally, they go together. But in this structure, they actually go together, but you're going to evaluate it, the else, only when this if has run through your while loop. When this if, okay, see, if and else, they go like this. So we have if, let's say true. Yeah, let me say something like this. If true, run some code. Then else, you run some code. So we have this kind of structure, but immediately you check your if statement here, and let's say it is not true, it's false. So let me just say false. So if it's false, it simply means that you're going to run your else block immediately, right? But in this way, this structure, you evaluate the if for the first time in the loop, evaluate the if for the second time in the loop. You keep evaluating until you finish your loop, okay? If you finish your loop, maybe your loop 19 times it went. After 19 times, if this if statement never held in the whole of the 19 times, then that's the time you now come and do your else.
Okay.
Something like that, yeah. But if at any time in those 19 times, that if side, this part of the statement is true instead of false, If at any
Mhm.
time this one now become true, so your code is going to hit break. And when your code hit break, if it's true in the if else block, the moment this part is true, you're not going to run the else. Abi? You
Oh,
only run the else when this part is false, then you
false.
now run the
Okay.
else. So, but this case now is somehow connected with the while loop, that the while loop will continue to run the whole of the condition, like in the case of 19, to run 19 times. And then when you did not hit break for 19 times, that is the time you now run else. But if in any of those 19 times you hit break, you will not run
It
else.
also. Okay.
It's just a structure on its own.
Okay.
A structure. That's just how it is for the while loop. So I think with this now, we've gone through the topics I outlined here for this while loop. The other part of it now is where we go back to our book. If you read the chapter, there are a series of examples too that can throw more light on this. Okay?
Okay.
Yeah. Then you enter into the exercises for solving. The more you solve, the more you get used to this while loop. Now, all these things we are doing, we have put, is like your toolbox is getting full. We are now in chapter 9. Sorry. Oh no, I'm not supposed to click it. We are now in chapter 9. We've come a long way. I'm proud of us. We are now in chapter 9. Okay. By the time we get to chapter 14, which will be in the next 1, 2, 3, 4, 5 weeks, we have finished this series.
Wow.
Yeah, I'm finished. In this book, our target is to come to OOP, Object-Oriented Programming. By the time we get here, you've understood the basics of Python, at least most of it. There are still some other things, like this part 2, graphics, intermediate topic, part 3. It's like a little bit more like gone advanced and the rest. So, but at least for this, our Python class, we target is chapter 14. Then the rest of this is kind of, if you want to keep doing, you can do it on your own. But by the time you get to 14, you pretty much have solid foundation in Python. Where we'll be going to from here is data structures and algorithm. So with data structure, pardon?
It's machine learning.
No, you want to go to machine learning.
I'm thinking about at what point do we get before we divert? He said everybody should follow one route. A point,
Back to
can
machine learning.
resist.
When you finish,
Mhm.
you can now go to machine learning. But you've not finished. I'm just saying for this book, right? And this series we
Okay.
are going through, the target is to get to object-oriented programming. And by the time you get to object-oriented programming, you have basics of Python very well.
Okay.
There are
Okay.
still some topics this book covers. They are just like not basic, advanced, right?
Okay.
Now, if
Yes.
you still want on your own, you can study them. But at this point, we now will now go towards data structures and algorithm and begin to
Okay.
explain some other concepts in Python. Now, those other concepts now is where you now get more confidence for maybe attending an interview. Now, if you have been following us and doing all the exercises, at this point in your toolbox, you've gathered quite a lot. When we now go to data structures, it's like building on all of this. Okay, when you now go to that point and you understand data structures and algorithm, you will also be very confident. Once you go to any interview, you can perform.
Amen.
Okay. Yeah. With what you've known like this and that one. Python is completed, at least for this series. But you can see it doesn't mean we've learned everything in Python. It's very vast. You cannot learn everything. After that, you can then go to machine learning. After that, you can then say, no, you want to be a data scientist with Python.
Data science.
Yeah, you can begin to branch into other things with Python. But you see, anything that has to do with foundation of Python is complete. Not just Python, programming. All these concepts, which we are just learning like this, if you go to JavaScript or Java, it's still the same concept you're going to be using. Okay.
Mhm. Mm.
I just thought to mention that we are really doing fine and we've come a long way. We are almost there. So we should be happy.
Kudos to you.
Kudos to us. So that's it
Thank
for
you.
that one. You're welcome.
So I have a question.
Yeah.
From your explanation, is
Okay.
it that chapter 15, that's the graphics, is just optional?
Yeah, for this our class, it's optional. But if you want to know it, it's going to be on your personal level. Like our class is not going to be doing these graphics, say, okay, let us now be teaching you the graphics and all this stuff here. Do you get it? Or do you want us to go through all of them?
I don't know. First, for me, since we started the book, everything that has a beginning has an end.
If you guys as a group say, let us go through all the chapters of this book, why not? Why not? But I'm just
Yeah.
telling you that with your understanding up to this object-oriented programming, you have already, if you understand it, you have already a good foundation in Python. Even if you complete this book, this is not all the topics that exist in Python. All these things you see in this book, there's still more that are not here. So at this point, it's like when you have foundational topics, then you have intermediate topics, then you have advanced topics. So by the time we get to 14, we have finished the elementary. Okay, which is already
Which will
good
serve as
enough.
a building block for chapter 15 till
Exactly, to the rest. So chapter 15 to the end is more like intermediate topics, right? A little bit of advanced. But I'm sure that even the topics like this one, recursion now, if they may not go so deep, but it can be advanced recursion now. Now, when we get to data structures and algorithms, are talking about it, we'll still indirectly cover some of these concepts they listed here. Like you see, first-class functions, recursion, all these kind of things. We'll use them, and then we'll talk about exceptions. We'll talk about them, but we are no longer following the book serially again. So it's not like we'll not be continuing chapter by chapter as we're doing now. Does that make sense?
yeah.
Yeah. Mhm.
Yeah, but if you want, we can, do it. Not a problem.
Let's do the next one. You talked about the data algorithm.
Data structures and algorithms. Okay, and we'll get there. It's not today, Well, I'm just telling us to look at how we've made progress, even though we are meeting. But keep trying your best. The main thing is you're participating in solving those exercises, right? Those are the real work. This is where it enters your brain.